group are about to embark on an expedition with the British Schools Exploring Society. They're on their way to the Himalayas, but not today. Today they're preparing for an experiment they will be taking part in during their trip. It's to do with respiration. Have you ever wondered why you get out of breath when you exercise, even if you're fit?
Come on, Benny! I've got absolutely no energy left. I'm having a rest.
Here, take one of these. It'll give you energy.
You lot seem to have energy to spare. Mind you, that's no bad thing where you're going. You're going to need a lot of energy soon. Are you thinking about what sort of food you're going to eat on the expedition?
Well, we're going to be walking for 6 hours every day through the mountains. That's for 6 weeks. That means we're going to need lots of high-energy foods.
Like what?
We'll be eating foods with those carbohydrates. Things like chapatis, rice, chocolate biscuits.
But it's not just food we need to get the energy. We need something else.
What do you mean?
Well, we're meeting someone at the top who'll explain it all. Come on, let's go.
I knew they'd run.
Ah, you made it then.
Hiya, David.
Hi.
Hi, Dave.
Come on through.
Hi, David.
Hi, what took you so long?
Is that
Come on through. Do you feel like you used a lot of energy coming up the stairs?
Absolutely loads, but nowhere near as much as the expedition are going to be using. Now, we talked about them taking high-energy foods, but where exactly does the energy come from?
Well, the energy we need is released by a process called respiration.
I thought we got our energy from food.
Well, food is an energy store, and carbohydrate is one of the best stores of energy. But it's not enough just to eat the food. We need also to release that energy to take in a gas from the air that we breathe.
Air is a mixture of different gases. It's mainly nitrogen and oxygen, with a very small amount of carbon dioxide. But which one of these gases do we need?
We can test to see what gas our bodies need by looking at the difference in the gases that we breathe in and the gases that we breathe out. As we know that the air around us is 21% of oxygen and only 0.03% of carbon dioxide. And if you'd like to pop the mask on, we'll have a look at the gas that you breathe out.
When I breathe out, the air only contains 15% oxygen, not 21% as before.
Well, that's a lot less than I inhaled, so I must have used up some of the oxygen when I breathed.
That's right. If you'd like to pop the mask back on, we'll have a look at the carbon dioxide that you breathe out.
Only 0.03% of the air I breathed in was carbon dioxide, but when I breathe out, that has increased to 5%.
That's over 160 times more carbon dioxide than the air you breathed in.
That's amazing.
And look, if you'd like to take hold of that and breathe out, you'll see another byproduct of the process. Water.
So, I used up oxygen and produced carbon dioxide and water.
And